Right. Yeah. So I think I will try to talk more about this methodology instead of having you present your synthesis model is because one thing, I mean, first, not everybody's here today, so I think. But also, I mean, even though in this lecture it's mostly about utility evaluation, but I will be talking about, I mean, in practice, how you can do the sequential synthesis, because I think for many of you, for your project, if you chosen certain models, I'm guessing most likely you're trying to do sequential, like univariate sequential one by one. So we talked about the general idea and why it works, but I think we haven't talked about in practice how you can do it. And it's not something, I mean, once you know how to do it, it's not that bad, but I think it's probably a good idea to walk you all through about the procedure, and then we clear up any kind of confusion we have, so that I think will put you in a better position in doing all of the synthesis that you will be doing for the project. So let's start with this. So for this one, I prepare some examples of analysis-specific measures. So now you know that the previous section is about the global utility, right? We're trying to compare like distribution, trying to use methods to discriminate between and to see if they can distinguish between the two data sets and all that. So that's at the global sense, okay? Yeah, but then most of the paper or the work that we saw, like say the synthetic LBD, right? And also, yeah, mostly synthetic LBD, we have seen those reported utility to be an analysis specific, right? Like they show you all of the graphs, like they're looking at particular analysis people might want to do and then compare them across the synthetic data and the original. So, so as you can see, the full picture not only includes global, but also analysis specific. So let me first cover a few ones. I mean, we already talked about, say, for continuous variables, so, you can look at the mean, the median, the regression coefficient, that kind of stuff to see how close they are. For categorical variables, just a toy example here so you can get a sense of what people usually can do. So for example, let's say I'm looking at this race category variable. If you remember, it has 6 categories in the CE data. And let's just say in the original data set, the percentage breakdown is in the second column here. Okay? And let's just say in a particular synthetic data, the percentage breakdown is on the third column. Okay? And anything you can think of, I mean, this is what we call one-way interaction because you're only looking at race. Because if you also synthesize, so this is the case that you synthesize race, okay? And for the CE data, remember we also have that, what is it? The urban rural status variable, which is binary. So for when you have more than one categorical variable, you can have, say if you have 2, like that case, you have one-way interaction and two-way interaction in the sense that I can create a contingency table for two categorical variables and then look at the percentage breakdown in there. Okay, so this is what we call like one-way interaction. So one thing you could do, many people actually doing that is instead of looking at the raw counts, we look at the percentages. So there are the frequencies, right? Frequencies, percentages in this case. And then you can look at, let's say for the first row, for race category 1, we know that the original is 0.8, right? The synthetic is 0.9. So we can look at the percentage difference. So that is 0.9 minus 0.8, but then you put it on percentage because, well, the magnitudes are different, right? The absolute, yes, I mean, the absolute difference wouldn't mean much. Okay? So that will be one way people want to summarize specific, like analysis specific utility for categorical data. So, I mean, for example, you can just add up all of the differences. I mean, the percentage differences, it's probably, yeah, I should just change that as well. I think it's probably best to return the absolute value, just because, I mean, positive and negative are going to cancel out, right? We want to, just like when we were trying to calculate variance, I mean, variance we take square and all that, but you know what I mean, like this will be a reasonable measure, okay? So this will be something you can use if you want, if you're working with categorical variable. And again, this is one way. If you have 2 ways or 3 ways, that is just when you're creating more like intersection of more than one variable, you will be able to create that. And then look at the percentages in the original and then in the synthetic, and then compare the difference. Look at the absolute value of the percentage difference, and then report that as the sum or like average, whatever you want to do. I think that will give us a sense of how good the synthetic data is doing. And specifically, in your project, if you want, you might want to try multiple synthesizers. I mean, synthesis models, you might want to. And then if you want to compare them, then say for a categorical variable or any like continuous variables you can think of, all of the analysis that you can do. And you might want to like use some kind of summary to compare them. So this will be a good example if you have categorical variables and to do the kind of analysis there. So another type, so this is from a recent work that I did. I mean, I just like took a screenshot from there. So if you have geographic information, then on R, you can produce heat map, and then looking at the darker the color, the higher the percentage. I mean, depends on specific other variable that you're looking at. So what we're doing here is looking at the percentages of high wage earners in Bavaria, by zip code level. So you can see that we can, the heat map, the method in R, the function itself will be able to create you the map and also just the. So this is in the original data. We have synthesizer number 1, synthesizer number 2, and synthesizer number 3. So this will be a way, if you have that kind of data, you can, plot, if you have that kind of geographic information, then you can look at particular other variable given the geographic information and see how things are doing. So that, open-ended, I just want you to be creative. If, when you're working on a project, you might have additional types of variables that you're working with, and then that will just require other types of analysis specific measure. Okay, so feel free, and happy to discuss more of how this is done. But again, this is very specific if you have geographic information that you're trying to synthesize. All right.